Okay. If the following current, oops, I said current. That's a voltage, isn't it? This should be voltage. These may be more typos, Ian. They should say voltage. I'll have to fix all this, okay? If the following voltage across a 12 ohm resistor is given by the following graph, determine the average power dissipated in the resistor. So once again, we need to find VRMS. What is the period for the voltage? What is the period? It's 20 seconds. I can pick any period along this to define that. I'm going to do the one that does not require me to take 3 integrals, okay? So if I start at 0, I got to integrate this line, and that line. If I start at 5, I only have to integrate 2 lines. Does everyone see that? So I'm going to do that. So I'm going to say the equation of this line is negative 2t plus 20. And that is between 5 and 15 seconds. The equation of the line between 15 and 25 seconds is 2t minus 40. Okay, why am I doing this? If I integrate from 0 to 20, I have to use 3 integrals. If I integrate from 5 to 25, I only have to do 2 integrals. B squared of t is going to be, I'll just put negative 2t plus 20 squared for now. And 2t minus 40 squared for this one. And I'm going to give you the answer. I know if you had time, you could do it, but it's VRMS squared equals 1 over 20, the integral from 5 to 15, negative 2t plus 20 squared dt, plus the integral from 15 to 25, 2t minus 40 squared dt. So if you do that, you get 33.33 volts squared. What's the power? Henry? 2.8 watts. 2.8 watts. All right. So the power is 33.33 divided by 12, which is 2.8 watts. Example 4. A relay coil is connected to a 210 volt RMS 50 hertz supply. If it has a resistance of 30 ohms and an inductance of 0.5 Henry, calculate the apparent power supplied to the coil. Okay. So here we have 210 volts RMS and 50 hertz, and it's connected to a coil that has an internal resistance of 30 ohms. Okay. So in the frequency domain, that inductor would be J 2 pi 50 times 0.5. Okay, because that's J omega L. So that is J 157 ohms. You bring me such joy, Alfred. No, it's not Monday. When I keep making mistakes, it feels like a Monday. Okay, there we go. Thank you. It's Thursday though, right? All right. Okay, so if I want the current, and this is going to be in RMS because the voltage was in RMS, it's going to be 210 angle 0 degrees over 30 plus J 157. So find that current. Find the current.
With an angle of negative 79.2 degrees.
All right, we'll just round a little. That's going to be amps RMS. 1.31 with an angle of negative 79 degrees. Did anybody else get that? Okay, so now I need to find the power delivered to the coil. So I'm going to find the average power, complex power, reactive power. So the average power is P equals VRMS, IRMS, cosine theta V minus theta I. Reactive power is Q equals VRMS, IRMS, sine theta V minus theta I. Complex power I can either do VRMS, IRMS conjugate, or P plus JQ. And then the apparent power is the magnitude of S times that angle with that angle. Okay. The apparent power is the magnitude of S. And the power factor is the cosine of theta V minus theta I. Okay. So those are all the values we could find here. Average power, reactive power, complex power, apparent power, and the power factor. Let's start with the average power. What is the average power? That would be 210 times 1.31 times the cosine of 79. 210 times 1.31 times the cosine of 79 degrees. Ryan, it's like just because I put my calculator down, that's when you start asking for stuff. 210 times 1.31 times the cosine of 79. $52.5 watts, okay? The reactive power is 210 times 1.31 times the sine of 79 degrees. 210 times 1.31 times the sine of 79 degrees. Peyton? 270 var, and I really appreciate you getting that var right. Good job. Okay, so then the complex power, I can just use what I have and write 52.5 plus J 270.7, and that units are volt amperes. 52.5 plus J 270.7 volt amperes. Then if I convert it to polar form, I get the apparent power. So in polar form, S is equal to 275.73 with an angle of 79 degrees volt amperes. What's the apparent power? $275 volt amperes. Right. Okay. What is the power factor? Cosine of 79 degrees. What's the power factor? .19. Okay. You always have to tell me lagging or leading. Whenever you write a power factor other than 1, is it lagging or leading? Leading, right. How do you know it's leading? Ian? It's an inductor. So the angle is positive and it is lagging. Remember, Eli the Iceman. Voltage leads current for an inductor, or current lags voltage. So because the current lags, we go by the current. Current lags, it's lagging.